Hi, this is Presh Talwalkar. How many triangles do you see in this picture? Give this problem a try, and when you're ready, keep watching the video for the solution. We need to count the number of triangles very carefully. We'll first consider triangles which have a size of 4, which means its side length is equal to 4 times the smallest triangle. There's exactly one triangle of this type, and this triangle is facing upward. Let's continue counting only the number of triangles which are facing upward. Let's count the number of triangles which have size 3. In the bottom row, there are 2 of these triangles, and one row above that, there's 1. So that makes for a total of 3 triangles of size 3 facing up. How many triangles are there of size 2 facing up? The bottom row has 3, the next row has 2, and one row above that has 1. 3 plus 2 plus 1 is 6. Finally, we count the number of triangles of size 1 facing up. The bottom row has 4, the next row has 3, the next row has 2, and the top row has 1. 4 plus 3 plus 2 plus 1 is equal to 10. Now we need to count the number of triangles which are facing down. We'll start by counting the number of triangles of size 1. The bottom row has 3, the next row has 2, and the row above that has 1. 3 plus 2 plus 1 is equal to 6. Now we count the number of triangles of size 2 facing down, and there's exactly 1. Now as you can see, this is the largest size triangle that's facing down. So there are no triangles of size 3 or 4 facing down. So we've now listed out all the triangles, and we can total this up to get that there are 27 triangles in this picture. Now what would happen if we want to generalize this for a base that has n smaller triangles? Well, we found a pattern in the shape we just saw. The number of triangles facing up of size n, the largest size, was equal to 1. The next size, there were 2 more of them. The next size, there were more of them according to this shape. Each time we were adding the next number in the sequence. These are the triangular numbers, which are the shapes you can form that have a triangular arrangement of shapes, and they're equal to the sum of the numbers from 1 to n. The triangles of the smallest size 1 were equal to the triangular number of size n. Now in many videos we figured out the way to sum up the numbers from 1 to n, and this is the triangular formula number, which is equal to n times n plus 1 over 2. To count the number of triangles facing down, we start from the triangles of size 1. This will be offset by 1, so we start out with triangular number of n minus 1. To get to the next size of 2, we had to offset it by 2, because each time the row is decreasing in size. So this is going to go about halfway up, and then the largest 2 sizes, many of the largest sizes, we're going to have 0 triangles facing down. So now we figured out a pattern and how to count the number of triangles of each size, and we have a formula for the number of triangular numbers equal to n times n plus 1 over 2. So this is actually going to vary whether you have n is going to be even or n is going to be odd, but there's a nice way you can summarize this if you add up all these numbers. The total number of triangles is going to be n times n plus 2 times 2n plus 1 all over 8 rounded down. This will give you the number of triangles. It's actually a sequence. The number of triangles formed if you have this equilateral grid of triangles. The sequence starts out 1, 5, 13, 27 was what we had when we had 4 triangles in our grid. It continues 48, 78, and so on. Did you figure it out? Thanks for watching this video. Please subscribe to my channel. I make videos on math and game theory. You can catch me on my blog, Mind Your Decisions, which you can follow on Facebook, Google+, and Patreon. You can follow me on social media at Presh Talwalkar. And if you like this video, please check out my books. There are links in the video description.